Grade 12s, welcome to question 3 of the same paper that we did previously. Question 2, the EC September 2019 Grade 12 mock exam. Question 3, we know question 3 is our vertical projectile motion question. Let's go ahead and read it. Of course, as per instruction in this paper, start on a new page. An object is fired vertically upwards with a velocity of 24 meters per second. After 1.5 seconds, it enters the branches of a tree. It emerges from the highest point of the tree and continues vertically upwards to a maximum height of 2 meters above the trees as shown in the diagram below. Ignore the effects of air resistance and other forms of friction experienced by the object during its motion. Okay, we see a beautiful picture there of a tree. We see the initial velocity, we see the 1.5 seconds, we see there's an unknown height that we do not know of, and we know that the tree from its highest point, from the bottom to the high point, 2 meters, it reaches above the tree, we see. Okay, we're not sure of the object, so maybe we can assume it's a ball or a stone. But in 3.1.1, they said calculate the velocity with which the object emerges from the branches of the tree, and that is for 4 marks. Alright, so this is an equation of motions question. We can definitely tell for 3.1.1. Okay, so we have to decide what do we have. We want to calculate the initial velocity. Let's just remind ourselves of that question, or the velocity with which the object emerges from the branches of the tree. Okay, so let's have a look here. We're going to use the formula Vf squared is equal to Vi squared plus 2. We're going to replace A with G for vertical projectile motion. Delta, not X, but because it's vertical, is delta Y. Then we're going to substitute. We know when the object reaches maximum height, it is 0 for a brief moment. It stops moving. Vi is what we are looking for, so Vi squared is unknown. Plus, the object is going upwards, so hence I'm going to choose upward as positive. So therefore, whatever is going downwards must be negative 9.8, because gravity is going down. Okay, and upwards is my positive motion or direction. And that's multiplied by 2. Right, so we can solve this all in on our calculator. Okay, we'll get a negative answer. We will move this all the way over to the left hand side, and then we will square root. Alright, we will square root the answer of 2 times negative 9.8 times 2. Whatever we get there will become positive on the left hand side, and we will square root our answer, and therefore Vi, or initial velocity with which the ball emerges, is 6.26 meters per second, and that is upwards. Okay, and that's pretty much basic over there. Okay, let's have a look at the next question. 3.1.2, calculate now the height, right, height h, above ground at which the object enters the branches of the tree. Okay, so basically almost the height of the tree trunk. Okay, so we can solve this quite straightforward. I was going to say straightforwardly, but that's not a word. And we can solve that by simply using the equation delta y is equal to Vi delta h. Sorry, not Vi delta h, Vi delta t plus half g for gravity delta t squared. Now, why are we using this formula? Because we know that it takes 1.5 seconds for it to enter the branches of the tree. So we can definitely use this equation. We substitute what we know. Okay, we substitute what we know for Vi. It says that it is fired upwards with a velocity of 24 meters per second. 24 times 1.5 for this section here, plus Now the object is going upward, so I'm going to choose upward as positive, times negative 9,8, because gravity is going down, so negative indicates a change of direction, times 1.5 all squared. Therefore, I plug that in straight on my calculator, and delta y will equal 24,98 meters, and we can therefore state it that unknown height h is 24,98 meters, and that will be our final answer for 3.1.2. The final question in question 3 is 3.3.2, says calculate the height of the tree in 6 marks, for 6 marks rather. So what we have is we have this height. Now we need to calculate what is the remaining height or remaining part of the tree where the leaves are, that stem. We need to find out what is that height. Okay, not to worry, we have equations of motion that can assist us with 3.2. Okay, so the first thing we're going to do is we need to calculate what was the final velocity, all right, from which the ball emerged. It entered in the tree. The ball entered at 24. We need to calculate the velocity from when it was in the tree. Okay, that period there. So for the remainder of this height, as it says in the question, if I could just remind you, it said after 1.5 it enters the tree and it emerges from the highest point of the tree and continues vertically upwards 2 meters above the ground as showed in the diagram below. So in the first question we calculated the velocity from which the object emerges from the tree, right? So from that point it emerged at 6,26 meters per second. What we want to find out is the velocity when it was still in this little motion over here. Okay, it entered at 24. What did it decrease to before it got to the top over there? Okay, and let's go have a look at that by choosing the equation. Vf is equal to Vi plus 2g delta t. Sorry, not 2g delta t, it's just g delta t. I apologize. Okay, Vf is what we're trying to look for. It's equal to 24 plus negative 9,8, because I'm choosing upwards as positive. If you choose downwards as positive, then your gravity will be positive and anything going up will be negative. Okay, time, can't have negative time, so it's just 1.5. Therefore, your final velocity is 9,3 meters per second. Okay, that's also going upwards. Okay, so now that would become your initial velocity in the formula. Vf squared is equal to Vi squared plus 2g delta y. The reason why this now becomes your Vi is because it was the initial before it left the tree at this point, because we know it left that tree at 6,26 all squared equal to 9,3 all squared plus 2 negative 9,8, again because upwards is positive and delta y is unknown, which is the rest of the tree. Okay, and if we solve, okay, we'd have 19,8, which is negative 19,6. So we'd have 6,26 all squared minus 9,3 all squared, and that would divide by negative 19,6 to give us delta y. And therefore, up top here, delta y should equal to 2,41 meters, but that is not the height of the tree. The height of the tree is the previous h that we calculated, all right, which was from the bottom of the ground until the beginning of the tree, or the bottom of the tree where the branches were. So that's 24,98 plus 2,41, and therefore that gives us a final answer. Height of the tree is equal to 27,39 meters. With that answer, we wrap up question 3 for vertical projectile motion. In the next tutorial video, we'll look at question 4.